Hey everyone, welcome back to the channel. If you've ever wondered how technology is transforming mental health diagnosis, today's video is going to blow your mind. We're diving into the world of ADHD, specifically how EEG spectrograms and deep learning techniques are making diagnoses smarter, faster, and more accurate than ever before. Don't worry if that sounds complicated. Stick with me and I'll break it all down. Let's get started. ADHD, or Attention Deficit Hyperactivity Disorder, is a neurodevelopmental condition that affects millions worldwide. People with ADH often struggle with focus, impulsivity, and hyperactivity, and getting an accurate diagnosis can be a tricky process. Traditionally, diagnosing ADHD involves questionnaires, behavioral assessments, and interviews. But what if there was a way to look directly at the brain's activity to confirm the diagnosis? Enter EEG, or electroencephalography. This is a technique that measures the electrical activity in your brain. The data from an EEG is usually presented as a spectrogram, essentially a visual representation of the brain's activity over time. It can tell us how different brainwaves are behaving. Here's where it gets really interesting. EEG spectrograms capture brainwaves like theta and beta, which are often linked to ADHD. In people with ADHD, research has shown that there's often an imbalance between these brainwave frequencies. Specifically, elevated theta waves and lower beta waves can point to inattention and impulsivity. Now, if we have all this brain activity data, how do we make sense of it? That's where deep learning comes in. Deep learning is a subset of artificial intelligence that uses neural networks to find patterns in complex data. It's like teaching a computer to recognize trends in a giant sea of numbers and images, but at a superhuman speed. In the case of ADHD, deep learning algorithms can be trained on large datasets of EEG spectrograms from both ADHD and non-ADHD patients. The algorithm learns the subtle differences between the brain patterns of the two groups. Over time, it becomes really good at identifying whether a person's brain activity fits the ADHD pattern without needing to ask a single question. Here's an example of what this looks like. On the left, you see the brain activity of someone with ADHD, and on the right, a brain without ADHD. The differences are subtle but significant. The deep learning model can spot these differences in a matter of seconds. Pretty cool, right? But this isn't just a theoretical concept, it's already happening. Researchers and clinicians are developing diagnostic tools that use this technology to improve ADHD assessments. It's faster, more objective, and can even track a patient's brain activity over time. By using these advanced techniques, doctors can potentially diagnose ADHD earlier and with more accuracy. This can lead to better treatment plans, more personalized care, and ultimately better outcomes for patients. Now you might be asking, what does this mean for the future? Well, we're looking at a future where diagnosing ADHD could be as simple as sitting down for a 15-minute EEG scan. No more long wait times for assessments, and no more relying on subjective questionnaires. As this technology improves, we may even see wearable devices that continuously monitor brain activity. Imagine a smartwatch that detects ADHD tendencies in real time, helping people manage their symptoms daily. Of course, we're still in the early stages of integrating EEG-based diagnostics with deep learning, but the potential is enormous. It's an exciting time for mental health tech, and I can't wait to see where it goes. If you found this video interesting, don't forget to like, subscribe, and hit the bell so you never miss an update. And if you have any questions or thoughts about ADHD, EEGs, or deep learning, drop them in the comments below. I'd love to hear from you.